Okay, we're going to be starting a unit on transformations today. And if you transform something, that just means that you're going to be changing whatever you're transforming. So, for instance, the Transformers. My son loves to watch Transformers, and they transform from robots into cars or vice versa. We're going to be transforming geometric shapes. And if later in life you get into graphic design, you'll be using these transformations a lot. There are 4 different kinds of transformations. There are translations, there are reflections, there are rotations, and there are dilations. So those are the 4 different transformations that we're going to be talking about this week. Today we're going to focus on the first 2. We're going to focus on translations and reflections. So get out your notes page and get ready to take notes to learn how to do these 2 types of transformations. Okay, so let's look at some vocabulary. First of all, a translation, you've probably heard it called a slide. And that's just moving a figure from one place to another. A reflection is a flip, or creating a mirror image of a figure. We're also going to be talking about a vertex, or vertices if you're talking about more than one. That's the point where 2 rays come together to form an angle. You might also call it the corner of the figure. We're also going to be talking about lines of symmetry when we do reflections. And that's just the line over which we're going to reflect our figures. So those are called lines of symmetry. So let's go ahead and look at some examples, or an example of a translation. Talk about how we can translate a figure. The first thing we're going to do when we're translating a figure is we're going to move each vertex or each point the same number of units as indicated by the directions. And we're going to label those new points with a little mark that's called a prime mark. Looks like a single quotation mark. Don't forget this step. A lot of people forget that step. We'll connect the points to recreate the figure. And the new figure should be congruent to the original figure. Remember, congruent means same shape and the same size. So it'll look just like the original figure. It will just be in a different place. So let's go ahead and take a look at our example here. It says, draw the image of quadrilateral ABCD after a translation of 2 units right and 3 units up. And notice that in parentheses, they've put the translation almost like an ordered pair. In fact, sometimes they won't give you the specific directions. They'll just say translate it 2, 3. And you know that the first number is X in an ordered pair, and the second number is Y. So that tells you to go 2 to the right because X goes left and right, and 2 would be positive, so it would be in the right, to the right, and then 3 up because Y goes up and down, and positive 3 would go up. So we're going to take each one of our vertices, A, B, C, and D, each one of these corners, and we're going to move them 2 to the right and 3 up. So let's start with A. If I move A 2 to the right and then 3 up, then it's going to land right here. Do that with a different color so you can see that. Right there. Remember, we're going to label that point A prime. Then let's take vertex B and move it 2 to the right and 3 up. So it's going to land right there. So that's B prime. Let's do the same thing with C. 2 to the right, 3 up, and label our new point C prime. Then D, 2 to the right, 3 up, and label our new point D prime. Then we're going to connect the points, and it should look like our original figure, exactly the same shape, exactly the same size, but just in a different place. Now if you go to the other side of the page, we're going to talk about how to reflect a figure. So when we're doing reflections, we want to plot each vertex, each point of the figure, the same number of units from the line of symmetry as the original points. So the same number of units from the line of symmetry as the original points. Again, we're going to label those new points with that prime mark. Don't forget those. We need to know which points are new and which points are the original. So we have to put a little mark on the new ones. Then we'll connect the points to recreate the figure. And just like with translations, the new figure should be congruent to the original figure. It'll be the same shape, same size. We're just going to flip the figure, not change its size or its shape. So let's look at an example of a reflection. In this example, it says triangle ABC has vertices, that means corners or vertexes. A is 0, 4, B is 2, 1, and C is 4, 3. It says find the coordinates of the vertices of ABC after a reflection over the x-axis. The x-axis is going to be our line of symmetry in this problem. Then it says graph the figure and its reflected image. Well, the first thing we're going to have to do is actually plot the original points, because that's not done for us in this problem. So I'm probably going to write down my original points and then graph those. Let's see, A was 0, 4. B was 2, 1. And C was 4, 3. So let's go ahead and plot those original points. 0 on the x-axis, then 4 on the y-axis for A, so that puts that one there. For B, I need to go 2 on the x-axis and then up 1 for the y-axis, so that's B. And then C, 4 to the right on the x-axis, 3 up on the y-axis, so that's C. Then let's connect our points to make our triangle. Now we're going to reflect that over the x-axis. So the x-axis is our line of symmetry. We're just going to flip that figure over the line of symmetry. And we're going to do that by counting for each vertex how far away from the x-axis is each one. Well, A is exactly 4 units up, so we're going to come back to the x-axis and go 4 units down from the x-axis, and that will be our new A point. We'll label that A prime. Let's go ahead and write the coordinates over here. A prime would be 0, negative 4. Then B prime is exactly 1 unit up from the x-axis, so we're going to make it 1 unit down from the x-axis. That'll be B prime. So our new point, our new coordinates for B prime are 2, negative 1. Then C is 3 units up from the x-axis, so we're going to make it 3 units down. So there's our new C prime. So now let's connect our points. Forgot to put what C prime was. C prime was 4, -3. Now, if you kind of look at what happened, if you look at your original points and then the new points, what happened was when we reflect over the x-axis, all we did was change the y values to the opposite of what they were. So +4 became -4, 1 became -1, and 3 became -3. Now, I don't like to remember rules. I can just do that and not have to remember the rule because I might get confused. But that's kind of a way you could check yourself, and you can tell that the x values stay the same and the y values became opposite. Okay, the last thing that we're going to do is they're going to already done a transformation on some figures here for us, and we've just got to describe what they've done. So let's take a look at a couple of examples for that. So on this first one, here's our original figure, FGH, triangle FGH, and then we have a new figure, F prime, G prime, H prime, and you can tell that those are the same shape and size. It looks like they just moved that figure. So we've got to figure out how much they moved it. So remember, when we slide a figure, it's called a translation. So we're going to write that this is a translation. I'm going to put translate because I've run out of room. And we can just count. It looks like F, they translated that 1, 2, 3 to the left and then 2 up. So it was a translation of -3 to the left and 2 up. Now let's make sure that that's true in G and H. So G, 1, 2, 3 to the left, 2 up. H, 1, 2, 3 to the left, 2 up. So we are definitely right about that. Let's take a look at our next example. Let's see what they've done here. Wow, that's quite a figure there. So we're going to just try to describe this transformation. So all I've got to do is look at one of my original points. So I'm going to take a look at H, and then I'm going to look at one of my new points. There's H prime. So I want to look at the old and the new of the same point. Well, the old point was 0, -3, and the new point is 0, 3. So if you remember back to what we just did a couple minutes ago, looks like all they've done is just flip this figure over, and our y values changed, but our x values stayed the same. So that means it had to flip or reflect over the x-axis. So this transformation is a reflection over the x-axis. Now sometimes they might do more than one transformation, but in this case they just reflected it. Okay, that's all the notes for today. Go ahead and get your practice page out and try those problems. Raise your hand if you're having trouble, or get some help from your partner.